All right, so last week we talked a bit about introduced to distributed objects, very much at a high level, and we sort of went into the DC system and talked about the global file and stuff like that. And sort of touched on the lifetime of a distributed object in terms of when it gets to generate, when it gets to delete, and all that. But I thought there was more room there to explore, so here we go. For today, we'll just still consider the OTP server kind of a black box that has several different clients to it. So OTP. And in there, you get the state servers, the databases, the client agents, and everything else like that. But what we're concerned with today is the clients of the OTP server, which are the UberDog processes, and we'll discuss these later on. But we have three main clients to the OTP server. We have the UberDog processes, the AI processes, and then the client processes. So, yes, the AIs are servers in their own right, but they're also clients of the OTP server. So what this means is each one of our shards or worlds is its own AI. So there's multiple AIs talking to, we're still just going to consider one OTP server here, just for simplicity. So multiple AIs, clients talk to the OTP server, and that's how they communicate with the AI. They don't have direct communication. There's no wire between these. Everything bounces off a message director in the OTP server. So that does not happen. So what we can do is send messages between each one of these clients. And that's generally done through the distributed objects themselves. They provide the functionality that lets you send updates to update the distributed object that lives on the state server. So and we'll get more into that, what a distributed object actually is right now, I guess. But most of us are pretty familiar with this concept. And we have the UberDogs and the AIs and everything. So when you think of a distributed object, one way that I found that helps out is to think of it as existing, like its soul exists on the state server. Everything else that touches the distributed object or displays it or sends messages through the system using it is only really using a view onto that object or a facet onto that object. And there are different views onto a single distributed object depending on what environment you're in. So the UberDog has its own view of, say, a distributed ship. So the kind of data that it has, or data that it can see, and the functionality that it needs and can use is different than the functionality that, say, the AI, distributed ship AI, has. And again, for the client, they have to render the things, so they deal with things in scene graph. And so what ends up happening is we have one object on the state server, but when you define your files and when you try to instantiate these objects, you end up having things like distributed ship. This one's for the client. Distributed ship AI, which is what an AI would see. And this is pretty obvious how this is going to go. So distributed ship UD is what an UberDog would see. And then there's a fourth one that's less frequent than the others, but is still pretty important. It's called distributed ship OV, and this one shows up on the clients in special cases. And what OV stands for is owner view, and again, we'll get to that later.
What does OV stand for?
Owner view. There's a few objects that use it. The avatars are the most famous ones. And it's basically, we'll get to it. Let's see. So what do we have? We have, everybody here sort of worked in the distributed system to some extent, I imagine. So is this clear so far how we have the different files representing the different environments that an object would be viewed in? I suppose. So this is the AI view. So when I need to do things like updating HP and everything, that kind of functionality would be on the AI. And so when it makes a change to it, it would say, okay, I just got hit by something like a cannonball. Now I have updated my HP locally just in my own memory space, but I want to tell everybody else in the world about it. And the way that happens is it sends an update on the object up to the OTP server. The OTP server decides, okay, this is stateful information. I have to change the state of the object, so it actually modifies the object on the state server. Once it does that, it uses those the tags, I guess, in the DC field or the DC file that you saw last week, like broadcast, RAM, ARC, those kind of things. So if it's a broadcast or broadcast RAM, I suppose in this case is what it would be, or DB. Anyway, a broadcast. If it's broadcast, it receives it on a state server, and then it sends it out to everybody that has an interest in it. In this case, would be all the clients. And interest is something else we'll get to, but basically, if it's broadcast, everybody who can see that ship on their client will get that message. Anybody who's on in another world or in a parlor game somewhere that doesn't know about that ship will not receive that message. So let's see. That's useful. So where do distributed objects come from? The majority of them are created by the AI. So the AI server can just create distributed objects in its own memory space and then tell the state server, hey, I need to put this out in the distributed space so everybody else can see this. And so it does that by instantiating an instance of the AI view of the object and then calling generate OTP object for generate online theme park object. So we would say ship equals distributed ship AI, and then you would give it the AI repository, which is a global object. And probably some other fields as well. And then you would call ship.generate OTP object. And then you would give it a location. So, and we'll get to, that's basically parent ID and the zone ID. So, when you create something, you would know where you want to place it in the distributed space. And that's the next thing we should talk about. But once you do this, it'll query all the data that you've defined on the ship, either in a init or in interstitial functions in here. And then transfer that state of the object up to the state server. And then anybody who's looking in the space where that ship now exists will now see that ship. So all these clients will start seeing that ship pop into existence. This might be a good time to talk about, I guess we can call it the distributed object hierarchy. So on the state server, it's similar to a scene graph in that you have nodes. It's a graph. So you have a root node up here, and then under that you have just a simple thing that goes like this. So, and every distributed object has a location in this graph, and the location is defined by a parent. So in this case, let's say this is our object that we're curious about. So the parent itself has a do ID, a distributed object ID, and on a state server, do IDs are unique. You won't have any collisions. So for just simplicity, we'll call this one object 200. And this is 32-bit space, I think. So they can get pretty large. You've seen them. They're like the 201, 00000 ones or something. So you have an object. The other half, and that's the parent ID. The other half of the location is the zone ID. And again, that's 32-bit space, so you can have a zone of 5004. So in this zone over here might be 5002. You can have an arbitrary number of objects in each zone, so it's kind of hard to draw this kind of graph, but you might have something like this. So and there would be those 3 objects all in the same location. So, and then let's give these guys some new IDs. So we got 301, 401, 501. So every distributed object in the game exists in this hierarchy somewhere. So when you do a generate OTP object, you give, say, the ship. Let's say it's just an AI ship, so it's not a database ship. So anyway, whenever you do a generate OTP object, there's a counter on the AI process that says, okay, allocate a new do ID. So in this case, we'll give it do ID 601. And that gets sent along with the generate OTP object message. So it says, okay, create this new object with do ID 601 in location, we'll say 401, and then zone 500. So what it'll do is it'll create our ship object here in zone 500 with do ID 601. And then once it's there, it starts, it can start receiving updates from the AI. It can receive other children onto it as well. So like if you board a ship, your avatar is parented in the scene graph, or not in the scene graph, in this distributed object hierarchy onto the ship. It's actually fairly fluid. Like you can, okay, so in practice it's pretty static, but avatars and I guess creatures are avatars, but creatures and stuff can move through. They get reparented to different islands, they get reparented to ships and everything. Sometimes whole branches of this tree get removed, so whenever you have gone into a temporary instance, so when you go into a cutscene, we put you into an instance that's created in this hierarchy just for the purpose of that cutscene. And then whenever your avatar leaves, we end up just pruning that out of the tree because nobody's going to see that anymore. So this is a pretty dynamic graph in that respect. A lot of things like the actual main world, they stick around forever. I'm talking in terms of pirates, but Toontown is similar to this. So anyway, let's see. And that actually, the moving around is a very important thing. There's the function called set location on every distributed object. And for the most part, we have the AI doing all the set locations, except for, again, this is in Pirates. The avatar in Pirates, we let the client do the set location. And that's to avoid certain race conditions and stuff where if the client and the AI both send a set location, they both are trying to sort of own the avatar at that point, you run into trouble. So we just say, let the client do it and do security checks every now and then to make sure things work out. And all the set location does is, it's basically a reparent to in the scene graph. It just says, okay, move this guy from here, maybe to over here in the scene graph. Everything under it moves as well. And the OTP server takes care of making sure everybody that needs to know about that move sees all the updates and everything for that move. And when we talk about needing to know about stuff, or whether you can see something, or whether something's visible, it's all talking about something called interest. So going back to this sort of split, the client is the one who's most interested in the different kinds of interest we can have. And we'll talk about those. The AI has pretty much a single interest. Anything that is beneath root up here in terms of locations. Anything that's under that tree, the AI automatically has interest. It's just AI interest. It's sort of the all-knowing process for everything under its purvey, I suppose. So it receives all the updates, we'll just say all the updates for right now. It receives this important state for all of its objects that it's managing, I suppose. Uberdogs aren't really stateful for the most part. They don't have really an idea of interest. They sit out here and sort of listen to messages that come directly from the AI. So whenever you want to talk to an Uberdog, it's very much, you open up communication like this through the AI and also through the client. But they are pretty agnostic about the AI worlds. They don't know where ships are. They can query that information, but they're not going to maintain that state. They don't get updates like the AI and the clients do. And the owner view is tied in with the client. So, interest. All interest is one of these guys telling, we'll just talk about the client, since AI's interest is pretty much taken care of. So all interest is the client saying, OTP server, tell me what happens in this location. And location can be, again, location is just a parent ID and a zone ID. So if I wanted to know about these objects, I would say add interest to this pair. And you do that on the client repository. I guess I just talked about the repositories. We'll get to that. So you say base.cr for the client repository. Add interest. And you give it, what's the syntax? It's something like, you give the parent ID, the zone ID. You actually give a list of zone IDs, but we'll just do one for right now. A name, so give it some string. And then there's an optional argument that's an event. And that can be important sometimes. So this is pretty powerful. What this is saying is, I want to hear about everything that happens in this location. So let's say you've just walked into a tavern and you want to know what's going on in the tavern. So let's say all the objects in the tavern exist in this zone. So when you walk in, the AI has given you this information through whatever means. You have to set that up. Somehow the client knows these two numbers. And then it says add interest here. When it does that, a message goes up to the state server and registers this interest with the state server. And what that means is the state server says, okay, you don't know anything about this area yet. I'm going to first tell you how to instantiate all of these objects. And then once I'm satisfied that you have all the information, I'm now going to start sending you any updates that I hear about for as long as you have this interest open. So, and that's when you start getting into those things like generate, announce generate, and then send updates. And then, so let's see. So let's say this object was just an NPC. It's an avatar in there. When you add this interest, like I said, it goes up. The state server says, okay, I know all this data. I will now send you a generate message. So we get a generate. So what will happen is the repository we talked about, didn't really talk about, but was mentioned, will receive that message, instantiate it in your client's memory space, and then call init, call generate, and then call whatever required fields have been defined in the DC file. Once all of those have been set, it'll call announce generate. So there's sort of a lifetime issue here. So we have init generate, and then we have required fields. So and that can be as many of you as you have defined. These fields are applied in the order in which they're listed in the DC file. So that's always guaranteed. And you have announce generate. Announce generate is just our callback to saying you have all the required fields now. You should be able to set up your geometry or something. Basically, it's sort of a distributed initialization call. And then after this, you start getting any fields that were labeled with RAM, broadcast RAM too. So any RAM fields basically. And DB as well. So, the reason for this split is because the RAM fields are not necessarily always set, and they can come in after generate as subsequent updates. You can also do that for required fields, but I don't know, the RAM fields are the ones that tend to change more often. And then so now your guy is generated basically. Oops. Is generated. And alive. So at this point, he's been placed into the doID table in the repository. He's functioning, you know. If somebody goes, you can now go up and interact with him. If somebody sends a message to him that says, you know, play the dance animation, distributed, like the AI says, okay, NPC, you need to dance. He'll start dancing, you know. That continues until one of two things happens. The AI decides to delete that object, or you remove interest. So we'll deal with the remove interest thing for right now, since this is sort of still the same thing. So let's say you turn around and walk back out the door. You no longer care about objects in this space. So what you do is you say, okay, state server, you know, I don't care anymore, remove interest. So now what happens is he starts sending back a parallel function called delete. And what this does is says, on the repository receives that and says, okay, I'm no longer going to be receiving any more messages or updates on this object, and we need to shut him down and pull him out of the table. Don't leave him in memory anymore. So you go to one function called disable, and then eventually you go to one called delete. So there's a bit of parallelism here in that disable and announce generate are tied together, and delete and init are tied together. So things that you do in announce generate, and while the object is alive, need to be cleaned up in disable. And then the leftover stuff that you initialized in init are generally cleaned up in delete. So when disable is done, the object should be returned back to a state as if it had just been initialized. So, and that includes things like cleaning up any tasks that might be running on that object, or messenger hooks. So if you did self.accept, be sure to ignore those somewhere and disable. And delete any important, I guess, object references off of it so that you get rid of the potential for circular references, which are a big problem in Python. The other way that this can happen, that you can get a delete, is if something happens either to where that object moves out of your interest or is deleted by the AI. To the client, it's all the same thing. That object went away, so you just deal with disable and deletes in the same manner. So And that would be, so let's say we just talked about walking out the door. So if the opposite of base dot add interest, space dot cr dot remove interest. So add interest actually returns something called an interest handle. I think it's just an integer or something. It's just something that helps the client repository know what you're talking about. So if you have stored this somewhere, which you really ought to do, so you don't start leaking interests, just say remove interest. And that will close down this interest right here. So these objects still exist on the state server. Everybody else can see them. It's just you no longer care about them. So your client starts cleaning them up. Let's see. There are a few different kinds of interests. Actually, we already talked about the AI interest. On the client, let's see, how many are there? There's the stated one, which is what we just talked about, where you just say, I want to know about this specific location. So, stated, Toontown has one called follow, I think. Does that sound right? So, I believe the follow interest means wherever your distributed tune is, your local avatar goes, you have interest in that location. So whenever you do a set location with your local tune, you immediately have an interest opened up for you. We don't do that so much in Pirates, but I believe that's done in Toontown. Let's see, so stated follow. There's another one for the streets. There's one there. Oh well. We have one in Pirates called a grid interest, I guess, where we use that on the ocean and on the game areas. So when you're running around and stuff, you're basically running on a grid. And what happens is, we've divided up the space into a grid like this. Let's see. And the size of the grid, the dimensions of it are arbitrary. But what we do is we say, if I want to add interest to this location, and this, so the entire, let's just go with the ocean. So the ocean has grid squares on it. Each grid square on there is represented by a location in the distributed object hierarchy. So whenever your ship is sailing across the ocean, we're actively changing its location in the distributed object hierarchy as you go from one grid to the next. So you have the same parent, but your zone is changing. So your parent is the ocean, and the zone changes as you go across the grid lines. What happens with the grid interest is we send up one thing saying, I want to add interest to this location right here. Let's say my ship is in the middle. So what will happen is we've made some rules that the OTP server follows. It says, when I open up this kind of interest, don't just give me objects in this location. Give me objects in these locations as well. And I think we went out 2 spaces, so we would get everything out there. But so the hard work of figuring out all these spaces and everything is being done on the OTP server. And all the client has to do is listen for the generates and updates and deletes as they move across the grid. So when they move here, these get closed out, and it opens these up. But one thing to keep in mind is the interests are completely separate from your local avatar's location. You can have your local avatar standing in one spot, but have interest open in 5 different places in the hierarchy. And we do that a few times. So you'll have, as many as 4 or 5 different interest handles open at any given time. What's another one? There was one more. It'll come to me. So I guess this would be a good time to talk about this event right here. So sometimes it's helpful to know when you stopped receiving generates for a particular zone. Actually, for a particular add interest call. So let's say there were, I don't know, 200 objects in here, and you wanted you want the OTP server to tell you when he's done sending all of those generates. You can ask the server to do that by specifying an event name right here. So what that'll tell the server to do is, while it's figuring out what data it needs to send you, it's also listening for any updates that these objects might receive. And so it hasn't sent you anything yet, but it's still just accumulating data. And when it's accumulated all the data, plus any of the updates that it's received while it was accumulating data, when it has it all there together, it'll send all the generates at once. And then at the end of that, it'll send a special message that just says generates or interest complete. And you can use that as an event to listen for whenever you add interest. So when you hear that, you know that you have everything in here ready and set up to go. And I think there might be a way to do that on the remove interest, but that's generally not used so much. And the trouble is that's pretty heavy to do. That's not free. Actually, Roger requests that we don't do that unless we absolutely need to. So a good example of this is the grid interest stuff. You don't really need to know when you've received all the objects out here, because I mean you're tearing across the ocean or something, and there's really nothing that you're waiting on. You don't need to know when you've gotten all the ships that you can see. You can just generate them and create them dynamically as you're sailing across the ocean. Some places where that is helpful, when you're coming into the world, sometimes that's helpful. You want to know when the game area is there. So you say, okay, send out this event. So when let's say you add interest to the instance that the world is in. So our hierarchy looks like the district, and then an instance world, and then a game area. So like Port Royal would exist down here. Let's see, district, and then we'll just call it main world since main world's an instance, and then just say Port Royal. So to get the main world, you would add interest to the district at this location, and then maybe you would put an event there. So whenever you get that event back, whenever you get that interest complete, you know that you have this main world now. And so now then maybe you add this interest. At that point, you then have, whenever that event comes back, you know that you have Port Royal, which means you can now put your avatar there with a set location. There are other ways to know when you have objects that don't require the OTP server to take care of that tracking. And it's called Related Object Manager. And it's actually pretty helpful. Do you guys mind if I erase, like, say this stuff? So the way Related Object Manager works, it's defined on the client repository, I think. So you do base.cr related object manager. So and then you do .request objects. And what you can do is you just give it a list of do IDs. So going back to say this example, instead of saying give me an interest complete whenever all this is done. Let's say instead the AI knows who exists here. So let's say he sends down all of these guys' do IDs and says, okay, here's all the do IDs, you need to add interest to this location, but don't bother with doing this event. So you can say, add interest, don't do the event, but give the related object manager that list of do IDs. And so you just give it the list, do ID 1. Oops. And you can specify an each callback as well as an all callback. I don't know, I think it's all callback.
That's right.
And so what happens is each callback is called for each object that comes in as it comes in. So, it takes one parameter, I think. So, and you can do whatever you want to with each one of those objects. All callback is called with the list of objects whenever they're all there, I think. So that actually takes a lot of work off of the OTP server, and it's useful to do that whenever possible. Yeah. Oh, that's right, AutoInterest. That one, not used very frequently, but sometimes it's useful. So in this case up here, so we had to add interest twice just to get port royal. With the AutoInterest, what you can do is define an AutoInterest at this object. Oops. So in the DC file, you can say anything in zone 10, I want to be treated as an AutoInterest. So what that means, it tells the OTP server, whenever I add interest to this location, also start giving me objects in zone 10 without having to add an interest there. It helps things on the client side, so you don't have to manage a bunch of interest handles. It doesn't really hurt or help anything on the OTP server side. One thing to be careful with AutoInterest, the interest complete event will only take into account objects in this location. So port royal would potentially come in after you received an interest complete. So that's where it also makes sense to use the related object manager, because this doesn't care about interest completes at all. It just listens for the objects as they come in. So if you can know the distributed object or the do IDs ahead of time, use the related object manager. If you don't know the do IDs or you don't care, then it doesn't matter. You don't use either of them. If you don't know the do IDs, but you still need to know when you have everything, use the event on the add interest. So yeah, that was kind of a really quick rundown. I'm sure there's a lot of questions. So anybody has any questions?
What happens if you create a cycle in the distributed object hierarchy?
I don't think you can.
Oh, you can't.
That would involve taking, there's sort of a special parent up here called the object server, which is a special hard-coded some value, I don't know, 4003, that isn't an object at all, but it's a place where the state server can place things. In order to get a cycle, you would have to have something, you would have to actually call a set location on this non-existent imaginary object underneath over here.
Okay.
So it's very much directed. So, do you have any questions?
Is it possible to get subsequent or multiple calls to be announced generate when you create an object? Could the announced generate be called multiple times?
You should not be getting multiple announce generates
On the same object?
on the same object.
It's a guarantee.
Yeah. If that's happening, then there's something gone horribly wrong.
I guess it's possible the object might be entering and leaving the zone repeatedly, but you would get it disabled for each
Yeah,
time.
you would, if you were getting a second announce generate, you would have to have gone through this at least to a disable. Yeah, let's talk about the disable stuff. So sometimes it helps the clients to cache objects away. So all the OTP server will send you are generates and deletes. With information comes with generate, the delete is just saying kill the object. It doesn't know anything about announce generate or disable or is generate or any of that. We put this little lifecycle thing on the client such that you don't have to completely destroy an object and recreate it in cases where you're running across a grid or that object is also moving across the grid and you'd have zoning issues. We do this on avatars and ships. I think that's it. Do we do it on something else? I think we just do it on the avatars and ships because they're fairly heavyweight objects, and it hurts if you have to sit there and tear it down and build it back every time it bounces over a zone boundary. So all disable does is, well, it does what you tell it to, but all it means is that we've torn down the object enough to where we don't have to load stuff from disk again, or we don't have to do flattening operations or something. It's no longer in the doID table, so for as far as the repository and normal distributed object game code is concerned, it doesn't exist. When it receives the generate again, it bypasses the init, does a generate, and then goes through, updates the required fields with the new data, and then announce generate is basically back into normal gameplay again. Yeah. So, and you can define that by, I think on the class, it's a class variable in your distributed class. I think it's just never disable. You set that to true.
I think cacheable. Is that
Cacheable?
None of that?
I'm sorry, yeah, you're right, cacheable. Never disable is something on avatars where we assume the client runs, or the client owns the avatar, and we don't want to listen to deletes from the OTP server. It doesn't make any sense to tear down the local avatar just because it walked out of your visible space. So I think that's the only one that we do never disable on. I haven't seen anything else.
Great. I think the global objects like the time manager might be never disabled.
Maybe the time
I think we just have
manager.
interest on them specifically.
Yeah.
There's some, we actually create them manually locally. There's no actual generate that gets passed to us. It's just they're there to receive messages. From
Yeah, that's the UberDog stuff. Is the time manager in UberDog?
Yeah, I think so.
Yeah, it's not, yeah, it's specific. So, UberDog objects are weird. They are not really distributed objects. They don't exist in this distributed object hierarchy. However, they do allow us to send messages through the DC messaging system as if they were objects. So what will happen is they're hard-coded. The OTP server reads a config file that has to agree with numbers that are defined in OTP globals or Pirates globals or Toontown globals, whatever they're defined. And it's sort of, the UberDog object can be instantiated in the UberDog process, and then an AI version of that, whatever needs to be in UberDog, will be, yeah, can be generated, not generated, but they'll also be instantiated, say on the AI or the client, whoever needs a view. Like the friends managers are a good example of this. There's a friends manager UberDog object, or process, and it has the friends manager UD. And on the AI, I believe, at least I know on the client, we instantiate a friends manager client view. And there's no doID in any doID tables that specify these things. But they can still communicate through the channels that have been hard-coded into the OTP server.
They're in the doID table, I think.
I don't know. If they're in there, they're not there by generates.
No,
So,
but they're
okay, so they may be in the doID table. But it doesn't help to think of them as pure distributed objects. But you can use them in the same manner kind of. They're a bit more complex. I mean, that could be a topic for another day. So we didn't talk about owner views so much. So remember how I said the owner views were important to clients? Every object in the distributed object hierarchy has a notion of an owner. Most of them are, like any of the objects that are created by the AI, most of them are owned by the AI. And that's okay, you don't need owner views at that point. Whenever the player though, whenever the avatar is set as the owner ID, it can now listen to any of the fields that you marked with own receive in the DC file. You will always receive own receive messages whenever somebody sends that message to the state server referencing that object, assuming you're the owner. And so in Toontown and Pirates, what we did was we split out the owner view from the regular client view of an object. So, for instance, we have, again, distributed ships. They have the distributed ship client object and the distributed ship owner view object. And let's say they both listen for the HP, or they both can handle the set HP call. If the AI updates a ship, a distributed ship, with the set HP call, the state server sends it down to, it's a broadcast message, so it gets sent down to all the clients. Everybody who has interest on the location where that ship exists gets the set HP for that ship. The owner as well receives it, even if he's on another shard somewhere, just by virtue of being the owner. He has an owner view, and what happens is whenever his repository receives that message and tries to route it, it decides, oh, okay, you don't really have the ship right now, but you do have an owner view. I will update your owner view with that message. If you do happen to be able to see the ship as well as have the owner view, both the objects get updated with the message. So if you're sailing your ship around, your owner view is getting updated and your ship as well is going to get updated. So, yeah, let's see. Owner views. Avatars can be set as you're the owner of the avatar. That's the big one. Ships, you're the owner of. Do we do it with inventories? I don't know if we do it with inventories.
They're weird.
Yeah,
Sure.
inventories are strange. All the ship parts. For Toontown, I think it's just the avatar. I haven't worked on Toontown in a while. So.
Can you explain like the shard concept in the context of zone ID or parent ID or location or something like that?
Yeah. So I was saying I was going to treat the OTP server as a black box, but this might be where we can look into a little bit. The OTP server is actually, I guess a good word's a cluster of servers. There are things like we talked about last time. There's message directors, client agents, state servers, databases. So a shard, in the way we think about it, is one instance of the game. So it has the main world, like in Pirates, it has the main world and all the islands. And so if we have 3 shards, we have 3 main worlds and 3 copies of all the islands. So let's see. So the OTP server is sort of a star architecture. We have a master message director in the middle. And then we have a bunch of other state servers out here. State server. Over here we have DB state servers. DB state servers. And then we have little message directors here that are like associated with each state server. So you get the idea. Talk, message director. AI is we start off the Python process that just says start an AI, and then we give it certain parameters. So I think we currently say 2 AIs per state server. And this is a shard. So 2 AIs share space on a particular state server. And what that does is it says the state server itself has this one, that sort of special object at the top. It's the object server. Object, I don't know what you want to call it, but it's a spot, it's a root, basically. And whenever the AI connects, it creates a district here. And then everything else is beneath that. So the way we have it set up is our single state server, I believe, has 2 districts on it. And then everything else is beneath the district.
So
Does that help?
Let's say if there is a pair of 201 and 5004, could the same pair exist on 2 districts?
No, I don't think so, because the way we set up our state servers and AIs and everything is we partition out do-ID space
Okay.
per each one. So I believe even across, it may be possible, but I believe the way we have it set up right now is every AI has its own unique do-ID space.
I think they each have 100,000 numbers.
Yeah, there's a lot of space there.
Yeah, so every new ID exists exactly once in the entire
In the
universe.
entire game, yeah. So yeah.
But the 5004 would be consistent, right? It's just
201 part imaging.
Right. Yeah, we changed the high
Yeah.
high numbers. So yeah.
It's probably worth noting that if you're looking at the code for it, the AI repository, like Pirate's AI repository, is actually the shard. Like they're both.
It's kind of weird.
Yeah, like the shard, when we create a shard, like a distributed district, it doesn't do anything, and we actually have all the functionality that's being sent through that on the AI repository. So they're kind of interlinked. So if you create an AI repository, you basically have one district, at least functionally.
Right, and that's completely
Sort of weird
not
thing.
the case on the client. So
No, not at all.
wouldn't make any sense there. Yeah, the repositories are interesting creatures. They take care of most of the hard stuff. They're the ones that, they're the interface between, say, the distributed objects and all this other state server stuff. So when you want to send a message, you call send update, you say ship.send update. Send update. All send update is a wrapper for functionality that's defined on the client repository that says, okay, pull out my do-ID, pull out my D class, my DC class, so distributed ship AI. It then goes in the DC file, figures out what kind of update you're trying to send, make sure you're giving the right values, and then packages that data for a message to be sent out on the wire. And we touched on that last time in the DC file discussion. So all that's handled by the repositories. And it's responsible for, like we said, bringing objects into existence whenever it receives a generate from the state server. And it also manages the interest. So whenever you add interest, you're asking the repository to send up that data to the state servers, or the OTP server, and say, I want to look at this space now. So, well, that's a little clearer. It's a lot of information. And I'm putting some stuff together. I haven't checked it in yet, but I'm putting a tutorial directory in Direct that will show you, like, how objects are created, what happens whenever you add interest, remove interest, whenever you set RAM fields. So like if a RAM field's not set, you won't hear about it here. But if somebody sets it, then next time you generate it, well, you'll hear it whenever they set it, but the next time it gets generated on somebody's machine, they'll get that data here. So just little quirks like that. So at some point, you'll be able to check that out and play around with it pretty quickly. So, I guess that's time. I don't know. Anybody have any more questions?
Did you talk about deferrable?
Deferrable? No. Deferrable is something we put in to help with some chugs and pirates, where I think that's right, yeah. So we found that whenever we walked into an area, if there were, say, 10 avatars there, it really hurt when you had to build all 10 avatars from scratch. So rather than taking like a 2-second chug or something, we said, okay, we'll just take 10 quarter-second chugs or something. Maybe not that big, but you get the idea. So we amortize the generation time out. So you can set a deferrable time, I suppose. So if you receive those 10 generates, you say only generate one every 1/5 of a second. So that way you get time to update your graphics and everything, and all your tasks get to run, at least for a frame. So you don't have a big stop. And again, I think that's a class level value similar to cacheable and stuff like that. So. Oh.